Okay, so we are going to take some quick notes here on acceleration. You will be using some of your skills from Wednesday when we were going over velocity notes. So you might need to refer back to the velocity notes video. You'll be using those story problem skills just to help you out with these. So acceleration, generally when we hear the term acceleration, we might think of speeding up. So like slamming on the gas in a car to speed up. While that is a form of acceleration, the physics definition is not technically just speeding up. So the physics definition of acceleration is the rate of change of velocity. So anytime you change your velocity, you are accelerating, whether it be in the magnitude of how fast you're going or direction. So it is a vector quantity. The symbol is a lowercase a, and the units are meters per second squared. So where we get those meters per second squared unit is our formula. So to find acceleration, we generally have a time frame in which you're seeing how much we're accelerating. So it's final velocity minus initial velocity over final time minus initial time. So our velocity units are meters per second, and time is seconds. So we end up with meters per second on top of the fraction, another seconds on the bottom. So that's where we get our meters per second squared unit. So acceleration is any change in velocity. So that means you can accelerate if you speed up. So if you increase your velocity, you can accelerate if you decrease your velocity. So we generally distinguish that between speeding up with the term deceleration to show that we're slowing down. And you could also you can also accelerate if you simply just change direction. So you could be maintaining a constant velocity, but still accelerate if you change direction. So a sharp right turn, you'd accelerate during that turn. If you're moving in a circle, then you'd constantly be accelerating because as you're going in a circle, you're constantly changing your direction. Answers you might find to be negative. So this either indicates a deceleration, so you slow down, or a direction change in the negative direction. So if you don't change your velocity, then you can't be accelerating. So as you are moving at a constant velocity and you never change direction, then you are never accelerating. So in that case, you're just maintaining like a constant speed. Unless you're told otherwise, though, you can always assume that we're moving in a positive direction. So you can always assume that positive directions are being implied, unless the problem tells you otherwise. Okay, so here we have what an acceleration problem might look like. So Kate walks east. 2 seconds into her walk, she has a velocity of 1 meters per second. And after 30 seconds, she starts to jog at 3 meters per second. So we want to see what her acceleration is during that time frame. So again, with the time frame that you're given, you're trying to figure out what are the initial and final values. So to figure that out, it's easiest to find the initial time first. So here's my 2 time frames. If I hit start on the stopwatch, whichever time would come first is the initial time. So 2 seconds would come before 30. So initial time here is 2. And then whatever the velocity is that goes with that 2 is the initial velocity. So at 2 seconds, at a velocity of 1 meters per second, so I have that V and those subscript I's to show initials. So 30 seconds would be my final time. And at that point, her velocity was 3 meters per second. So my unknown, I'm looking for A. My formula, final velocity minus initial over final time minus initial. So I go back to my givens. So final velocity was 3 minus initial 1 gives me 2 on top over 30 seconds minus 2 seconds, 28 seconds on the bottom. When I divide this out, I get that A acceleration is equal to 0.07 meters per second squared. And since I do have a direction up here east, I am going to include that with my answer. So she's still walking eastward. Now you have a homework set that has some acceleration problems. The 4 on the front are easier, more conventional problems, problems that you'll be expected to do come test and exam time. On the back are 4 more difficult problems. So problems from the hard section in your textbook, or a couple of college level problems even. So there's 8 problems total. I'd like you to pick 4 of the 8 to do. There's answers next to, at the end of the problem, so you know if you're getting the answer right or not. If you do the first 2 or even 3 and you're like, hey, these are really easy, try one on the back. I do have which ones are the easiest and most difficult labeled on there. Try to push yourself and challenge yourself. If it takes you a few times though to get an answer right, then just stick with the 4 easy ones on the problem. That's the bare minimum that I'm looking for you to be able to do. And if you can do those, then that's great. But if you're getting a little bored and you want to challenge yourself, pick a few of those on the back to do, and give yourself a chance to push yourself with these physics problems. But you only need to do 4 of the 8, and you can pick which 4 you would like to do. If you have any questions, email me. Otherwise, have a good day.